They say life is a beautiful lie and death is a painful truth. As much as in real life and death add so much dimensions to a video game. We'll be implementing a health system and our characters will turn into ragdolls when their health reaches 0. We're building the foundation of a combat system and more complex characters overall. So our character has an NPC script. We're going to create an NPC health script and add it to the character as well. And we need our NPC script to have a reference to that object. However, we don't want a direct reference. Separating your scripts is considered good practice in general, but in our case, we want the flexibility of being able to define different types of healths. For example, if your health system is defined in terms of hearts, like in the Zelda games or in the Binding of Isaac, or if you have health generation, or maybe your NPCs are vehicles and their health system works differently. So we want to keep this flexibility. So we're going to implement an iHealth interface and we're going to have our NPC script have a reference to an iHealth object. The iHealth interface defines some properties. We have points, max points, and an alive boolean. Points or max points are floats. And I see a lot of tutorials on YouTube use integers for health points. That's not going to work in most cases. For example, if you want a health regeneration system where the health points gradually increase over time, if you use integers, that's going to be problematic. Not impossible, but problematic. The easier way is to have health points as floats. NPC Health will also implement an iDamageable interface. This interface has a damage method with damage info as parameters. So why did we separate between iHealth and iDamageable? Why not have just one interface? That's the reason why this system is the most flexible. Right now, the character has one instance of NPC health, but let's say you want each limb to have its own health. If a bullet or an explosion damages the leg, we're going to look for an iDamageable object in the hierarchy of the leg. If your leg has a component, for example, limb health, and this component implements the iDamageable interface, then we're going to apply the damage on that component. If not, we're going to look for an iDamageable in the hierarchy above the leg. So we'll end up at the root object of the NPC. And here we have NPC health, which implements the iDamageable interface, and we'll call its damage method. So this separation allows us this flexibility. If you want a centralized health system in your character, you are able to do it with this structure. However, if you want the limbs to have their own health system, or for example, if you have vehicles and you want a separate health system for each tire and for other parts of the vehicle, then you can do it as well. And the iHealth interface represents the overall health of the entity, be it a character or vehicle or anything else. Actually, our NPC health component, since it's going to derive from the NPC component script, has a reference to an NPC. However, the NPC does not have a reference back to the NPC health. In the NPC component, we'll define some events like died and revived. So when the health points drop below 0, we'll call the died event. And when the points are below 0 or equal to 0 and are set to a value greater than 0, then we'll call the revived event. And these events are actually very important for our NPC ragdoll. So the NPC ragdoll component will also be part of the NPC object and will be responsible for enabling and disabling the ragdoll on the character. So the NPC ragdoll will subscribe to the died and revived events and will enable the ragdoll when the NPC dies and disable it when the NPC has been revived. So the revived event is useful in case you want to respawn your characters. Maybe in your game, characters don't need to respawn. However, if you use a pooling system to recycle the characters and you want to recycle a dead character, this will come in handy. So in Unity, we're going to use the ragdoll creation wizard to create a ragdoll. This wizard will create a collider on the various body parts of the character and will also add a rigid body and a character joint. So even without the ragdoll effect, these colliders are useful for damage localization. So for example, if you want headshots to count as double the damage, maybe you can add a component to the head called damage multiplier, and that damage multiplier will multiply the damage by 3, then send it to the iHealth component on the root object. We're not going to do it right now. This is a suggestion. Now, how do we enable the ragdoll and how do we disable it? So our character has an animator, and as long as this animator is active, it has full control over animating the character. So when the character is alive, we want this animator to be enabled, and we want the NPC ragdoll to set every rigid body on the limbs to kinematic. That in fact will disable the ragdoll, and when the character dies, we want to disable the animator and then set every rigid body to non-kinematic. We also have a character controller on the character. So when the ragdoll is inactive, this character controller will be active. And when the ragdoll is active, we want to disable this character controller. And since the character controller, which is a collider, and the other colliders on our ragdoll parts will be active at the same time, we need to separate them in different physics layers so they don't collide with each other. So we'll create a separate layer for the character controller and a separate layer for the ragdoll colliders. Let's create our layers. Let's go to Layers, Edit Layers. Here, create a ragdoll layer and a character controller layer. Then we need to go to the project settings in Physics and disable the collision between ragdoll and character controller. Now let's create our ragdoll. Go to Game Object, 3D Object, Ragdoll. Here you need to assign the bones of the hierarchy into the appropriate slots. I'm going to assign the hips object to pelvis, left hips to left leg, right hips to right leg, left calf to left knee, left foot to left foot, left shoulder to left arm, right shoulder to right arm, left upper arm to left elbow, and right upper arm to right elbow. And middle spine, I'm going to set it to spine 2. Then head. And here you can choose the total mass of your rig and then hit create. This will create a collider, rigid body, and character joint on each of your selected bones. Then you most likely need to adjust the colliders to fit your mesh. So for example, we can go to spine 2 and then change the size. So just make sure that the sizes of the colliders match your character. Okay, now that we have a rig, we're going to implement the NPC ragdoll and NPC health scripts. Before we dive into the code, I have to say a word about prefab organization. I decided to make one NPC prefab. So it has NPC, NPC animator, NPC look, NPC sensor, and the new scripts that we're going to make today. It has a nav mesh agent, character controller, and animator. And then in the hierarchy, it has a speech bubble, and that's pretty much it. So here I have my prefabs folder and my NPCs folder. This character is in the base subfolder. And then here we're going to have like civilian NPC. It's going to be a prefab variant. So here the character is using a different material, and it has a civilian AI, which has an AI controller and a behavior tree. This civilian AI is pretty much just the wonder behavior that we made in the previous videos, but we're going to add more stuff to it in the coming videos. This is a better way to organize your character prefabs. So for example, if you make your ragdoll, you only have to make it once, and all the other characters, by which I mean all the prefab variants, will have that ragdoll. And if you decide to tweak it or change the size of the colliders, then all your prefab variants will have these upgrades as well. In the NPC script, let's create a region called health, just to keep things organized. Let's add a reference to an iHealth called health. Now the alive boolean will be a property with a getter. If health is null, we'll return true. So characters without a health component will always be considered as alive. And if a health component is present, we'll return its alive property. And let's define two Unity actions, died and revived. Let's create our health and ragdoll scripts. In AI Mastery Scripts NPC, create a new folder called health. Here we'll create damage info, iDamageable, iHealth, NPC health, and NPC ragdoll. Damage info is a struct with a damage property, and we implement an implicit operator, so we can assign a float value to a damage info variable. iDamageable is an interface with a damage method that takes a damage info as parameter. So we could use a float here. However, we want to leave room for improvements. Maybe you want to know what kind of damage your NPC has received. Maybe it's a fall damage. Maybe it's damage from a gun, from an explosion, from fire. And perhaps we need to know who caused this damage and from which direction this damage is coming, and if the damage is even directional. So by using a struct, we leave a lot of room for these improvements. iHealth is also an interface with 3 properties: points, max points, and alive. For points and max points, the classes that implement this interface have to define a getter and setter. However, for the alive property, they only have to define a getter. NPC health is an NPC component that implements the iDamageable and iHealth interfaces. Let's implement the iHealth interface. We define a protected float points. Then we define a public property points with a setter and a getter. We'll come back to the setter shortly. Then we define a protected float max points. Then a max points property, which simply returns max points, and when setting it, sets it to the maximum between 0 and value. Then we define an alive variable set to true by default. Then we define an alive property that returns the alive variable. In the setter for the points property, we assign value to points. Then if alive is true and points have reached 0, we set alive to false, and we invoke the died unity action on the NPC. However, if points are greater than 0, and alive is false, we set alive to true, and we invoke the revived action on the NPC. Let's override the setNPC method of the NPC component. Here we're going to call base.setNPC. Then we're going to set the health reference on the NPC to this object. Let's implement the damage method of the iDamageable interface. Here we simply subtract the damage value on the damage info struct from the points. Then we add some methods to test health from the context menu. Here we have test kill, which sets points to 0. We have test revive, which sets points to 1. Then we have test damage, which subtracts 10 points of health from the points property. Let's make our NPC ragdoll script. It's going to inherit from NPC component. First, we define the ragdoll root. That's because we want to add some methods to the context menu to scan all the rigid body of the ragdoll parts. Of course, you are free to do it manually. However, if you're lazy like me, you want to do it automatically. So we're going to keep a list of ragdoll bodies and also the ragdoll colliders, and I'll explain why. Let's override the setNPC method. In here, we're going to subscribe to the revived and died actions, and we define the callbacks onDied and onRevived. In the onDied callback, we're going to activate the ragdoll, and in the onRevived callback, we're going to deactivate the ragdoll. In the start method, we're going to set the ragdoll to inactive. Then we implement a scan ragdoll components. This is the method that we're going to use from the context menu to scan the colliders and rigid bodies of the ragdoll components. So this is a very simple method. We assign both of these lists to ragdoll root.get component in children, and we get all the rigid bodies in the hierarchy of the ragdoll root and all the colliders as well. Then we define a method called setCharacterControllerEnabled that will simply enable or disable the character controller at the root of the NPC object. So here I'm checking if it's null, because for some NPCs, maybe they don't use a character controller at all. For example, if you have vehicles. My example is not really that relevant, because why would you turn a vehicle into a ragdoll? That doesn't make any sense. But anyway, we just cover our backs. If the character controller does not exist, we don't do anything. Now let's implement the setRagdollActive method. First, we call setCharacterControllerEnabled with the opposite value of active. Then we toggle the animator. Same as the character controller, we set the enabled boolean to the opposite of active. Here I used to also disable the colliders. However, these colliders on the different body parts are important for more than the ragdoll effect. So for example, if you want to implement limb-based damage like we discussed earlier, these will be very useful. We don't disable them. Therefore, this list of ragdoll colliders is useless. I'm keeping it just in case, it's not really important. Then we toggle the kinematic status of the ragdoll bodies. So for each ragdoll body, if the ragdoll is active, we set kinematic to false. And if the ragdoll is inactive, we set it to true. Now let's go to the player controller script. Here, if we call the character controller's move method, we'll get a whole bunch of warnings in the console. So we check if the NPC is alive, and only then will we call the move method. Same thing for updating the NavMesh agent. We check if NPC is alive. And in the update movement method, if NPC is not alive, we return. However, we'll still apply gravity and update the look angle of the camera, even when the character is dead. In the AI controller script, in the set NPC method, we need to subscribe to the died action. And here at the top, when the old NPC is not null, we unsubscribe from it. In the onDied callback, we set the agent's isStop to true, update rotation to false, and we disable the NavMesh agent. Then we deactivate the whole AI controller object, provided the AI controller is in an object in the hierarchy of the NPC. Be careful here, if your AI controller is at the root of your NPC object, this will disable the whole NPC object, and we don't want that. And in the onSet destination callback, we make sure that the agent is enabled before calling set destination. Okay, let's test our scripts. Here I have my player NPC. I'm going to right click, then click on properties. So we can have this floating inspector here. Okay, so this is our character. I'm going to go into the NPC ragdoll script. Before running the game, you have to set your ragdoll root and then hit scan ragdoll components in edit mode. Then click on scan ragdoll components in the context menu. And this will fill the list of ragdoll colliders and ragdoll bodies. And here I have my NPC health script. So I'm going to click here and test kill. So as you can see, my character has turned into a ragdoll. The animator and character controller have been disabled. And if I click on test revive, the character controller and animator are enabled again. And the health points are equal to 1. So our health script is working. Let's test the damage as well. Test damage. Our character has turned into a ragdoll. Let's test reviving it. Alright, so that's the first step to making a combat system and more complex AI behaviors. Next time, we're going to implement a basic weapon system, and we're going to see some cool improvements to our behavior tree system. Until then, see you later.